lower back arch position by use of 3 pool noodles. We see the flat back position by lifting your legs off the ground. Testing procedure. We use the indirect method by Adams 2002 to determine the 1 repetition maximum load. 3 trials were performed with using an 80% 1 repetition maximum load, and subjects were given 3 to 5 minutes of rest, or even more if they desired. Why? Because we did not want to introduce any fatigue effects, because this would have affected the results. Subjects were trained to keep vertical movement of the bar at an approximate constant velocity, and testing was stopped if subjects felt any discomfort or fatigue. We made sure to randomize the position because we did not want any patterns to develop. Data collection. Over here, you see we placed bipolar electrodes on the anterior deltoid, the upper chest, and the lower chest. You will see here that we marked points at origin and insertion. Now, you need to remember, or if you don't know, that the ionic electrical activity propagates longitudinally along the muscle fiber. So therefore, the bipolar electrodes needs to be placed longitudinally so it can capture that volume of ionic energy. So this is why it's important to mark these points. And what we did, usually for a muscle, the innervation zone, that's where the nerve meets the muscle, is at the midpoint or where the muscle belly is largest. So what we did is offset 2 centimeters from that innervation zone. Reason being, at the innervation zone, the EMG activity is attenuated. Because remember, the electrical activity is propagating away from the innervation zone, and it builds as it propagates away from the innervation zone. So we offset that 2 centimeters off the innervation zone. Just remember one thing, positioning of electrodes will affect EMG activity. So once you place these electrodes on the subject, you must leave them on, perform all your tests, because if you come back another day to perform testing, there are physiological changes that will occur and you will get different results. Okay? So we use 2 power lab systems coupled by a common trigger. Signals were sampled at 1000 Hertz for anisometric tests and filtered at 10 Hertz high pass and 500 Hertz low pass. The filtered EMG was full wave rectified, integrated, time normalized, and expressed as a percentage of maximum mean integrated EMG. A repeated measures ANOVA was used to determine overall differences in EMG activity for the 5 positions for each muscle. We use a probability level less than or equal to 0.05 to determine significant differences. So in summary, the steps for using surface electromyography, we had skin preparation, electrode placement, signal detection and recording, signal processing, and finally statistical analysis. Results and discussion. Over here, we see the physical characteristics of our participants. Over here we see typical raw EMG signals from the upper chest, lower chest, and the anterior deltoid. Data analysis. Based on the p-values for the upper chest, lower chest, and the anterior deltoid, there was no significant difference. As we see here from these p-values of 0.778, 0.19, and 0.068. So there was no significant difference for change in scapular mobility and lower back orientation. Here's a summary of all the results of the data there. But we can't speak too much of this because remember, we did not find significant difference. All right? So statistically, results imply that any of the 5 positions can be used for maximizing EMG activity. Accelerations and change in torque can contribute to variations in EMG activation levels. So if your speed of lift changes through the concentric phase, what is going to happen? Acceleration produces what? Force. Greater force will produce greater activity in the muscle. So this needs to be controlled for. Time normalization was used also. We had to standardize because we found that subjects took from 2 to 5 seconds to perform the lift. Remember, increase in time would lead to increase in total EMG activity. So we standardized and found per unit time. Summary and conclusions. So we accept the null hypothesis because no significant difference was found, and any of the 5 positions can be effectively utilized for maximizing recruitment for the 3 muscles. Now, since no significant difference was found, that means using the pool noodle versus using the flat bench surface, it will be safe for you to use a contoured surface that allows free retraction and protraction of the scapula, and it would not affect EMG activity of the muscles involved. The LBF, the flat back position or the naturally arched positions, can be effectively used to recruit the 3 muscles investigated. Note that I left out the extremely arched position because we know that the extremely arched position can cause impingement of nerves in the lower back. Right? And lastly, recommendations for future research: examine the effects of range of motion on muscle hypertrophy, examine beginning bench pressures for the effect of scapular mobility on shoulder discomfort, because remember, powerlifters, bodybuilders, fitness enthusiasts would have developed specific scapular control patterns. So it would be interesting to examine beginners and see how it affects the shoulder. Investigate the effect of training the flat back position on the 1 repetition max for the horizontal bench press. What we noticed for the powerlifters, when they did the bench press with their legs off the ground, we saw a markedly increased EMG activity in the upper and lower chest because they would probably be using that drive from the legs to assist in the motion. So it changed their body position and increased their activity. And lastly, standardized period and speed of lift. So coming out of this research, most recently, I have created a prototype therapeutic exercise counter support. We will soon begin testing that. What it does, it will allow your scapula to retract and protract naturally. It will provide support for your neck and for your lower back. And if you're interested in this research, you can contact me at this email address. Thank you.
Thank you again, Dr. Jagasa. I'd like to actually thank all the panelists up front for their contributions and sharing their findings with us. I'd like to open the floor for questions. We won't take them sequentially, because I know it's very easy to forget what you're going to ask. There's a mic on either side of the center section. If anybody has any questions. So I'll take Ms. Gibson in the back first.
Good morning, everyone. This is not really a question, though it's a comment for Dr. Youssef. I'm the performance analysis testing officer at a sport company and also an exercise physiologist by profession. I was really glad with your presentation as it relates to brain and neuroscience. Actually, I did my dissertation master's as it relates to mental fatigue and endurance performance. What I could tell you, as it relates to research in Europe, we're actually getting licked with because it's trying to counteract the peripheral fatigue that has already been established before. And being a new area, it is actually causing controversy. But I would be willing, and I would love to actually work with you pertaining to that, because I believe that the mind controls the body, and depending on the type of research that you do and the athletes that you actually select for it, it's going to be a challenge, but I'm willing to take that challenge with you. Thank you.
Morning. I was wondering, Miguel Chagasa, my question is for you. I noticed in terms of the position and the weights that you had no weights under 100%. If you can explain to me why, and if you had at all looked at weights, because the bar itself is marked, and anyone who's been at a gym knows that the bar is marked below 100% as well, because the 100 would be, I assume, here, right? So, and you went to 190, which would be out here. So if you, you can tell me why, that's one. Did you also look at the difference in recovery times between the individuals and factor that into your research? That was another question for you. And thirdly, really, really quickly, how about the effect of the load versus the number of reps on your EMG data? Thank you.
Right, to answer your first question there, you mentioned about the 100 to 190%. Yeah, that was based on previous research. That was not my research. So that's the literature review. They looked at varying widths of grip to look at the EMG activity. Your second question was?
Recovery times.
Okay, recovery times. You will notice that I gave subjects 3 to 5 minutes of rest. The research has shown that at least you need 3 minutes of recovery time for ATP levels to regenerate. So therefore, we stuck within 3 to 5 if they needed more rest. But remember, the subjects would only be performing 1 repetition at a time. And we use 80% of the 1 repetition max load, not 100%, because if you use 100%, you could most likely have that subject fail in. All right, and then you would have to redo that whole test again, come in another day. And your last question?
The second would have negated the last.
Okay,
Yeah.
all right.
Good morning. My question is to Mr. Farid concerning neurostimulation. What is the feasibility on a daily basis for using TMS? And can we stimulate the brain and, of course, have the same results by using conventional methods? As the lady said here, it's a question of neurotransmitters to depress or to stimulate the brain. So we know of amino acids that can do that. So is it not just a question of business?
Thank you. I'm not sure if I got the last part. Most of this research is quite new, and technology is evolving. Currently, the protocols for TMS, as far as I know, and let me just say, I'm not an expert in any of these areas, to do it on a daily basis is going to be quite difficult right now because the technology does not allow small-scale portable units. But I do think we have to be aware that the technology is advancing very, very quickly, and people are already pushing the limits of this. And therefore, I'm raising it as something that we should at least be thinking about. I think your next question pertained to not the use of transcranial magnetic stimulation, but manipulation of neurotransmitters and these types of things. And I guess that would then go to whether you wanted to develop drugs or pills or those types of things. Let me just say there's a lot of work going on involved in this, including the military doing it as well. So people are looking. I can't tell you what they will find, but people are looking.
Just stand.
Hi, good morning. My name is Archie Leiber from UV Open Campus. My question is for generally. It's concerning about mind. You all talk about mind, biomechanics, neurophysics, elite. I also am a martial artist and I also teach children with disabilities, but I'm hearing anything about nervous systems. all right? Especially like brain loss and stuff. So that's for general.
So what's the question exactly?
Nervous system. Nervous system. You are not using the words like for nervous system. I'm mostly like a old school. Like, you know, you're dealing with students with like the old time need rice, right? I not hear anything about the rice, like nervous system. You're talking about muscles, you're talking about the mind, but nothing about the nervous system in your to discuss like nervous system. General, actually, talking about hamstrings, body parts, but not nervous system, like nervous.
Well, I guess when I was using the term the brain, I was using the term the brain collectively to refer to the entire nervous system. I think by focusing on the brain, I was making a difference between the central nervous system and the central control of bodily function that occurs in the brain, as distinct from the autonomic nervous system and those nerves which over the years a lot of people have spent time looking at, which is important for regulating heart rate, respiratory